Hi everyone, I'm Rose. I work at AIMS on the Modelling and Decision Science team. Today I'm going to talk a little bit about ADRIA, which is a decision support tool that I've been working on with a whole lot of other people. So it's led by Takuya Iwanaga, but also with a whole lot of other researchers. But I'm going to talk about, firstly, how we're using synthetic data to test ADRIA during its development. It's in active development. And also how we can use synthetic data to ask questions about restoration strategies and more generally how it could be used in reef modelling. So firstly, what is synthetic data, you might be wondering. It's data that is built to replicate the statistical properties of an original data set. And that could be using statistical models or machine learning models. There's a whole lot of different techniques you can use to do this. I've got this slightly creepy image as an example. So the images in the top are real images of eyes, and the images below are simulated synthetic images. So you can see there's a statistical kind of similarity between them, but you can generate a lot more images in using a synthetic data model, and you can also enhance certain qualities of those images. So why might we want to use these techniques for reef studies? One reason is privacy and sensitivity concerns. So some reef data might be sensitive to certain stakeholders, maybe traditional owner rights holders, potential investors in reef restoration projects. So maybe you want to do a model demonstration. I'm not saying you're going to actually make decisions using synthetic data, but maybe you want to demonstrate a model in a publication without revealing the original data set. Another reason might be you want to generate larger volumes of data for model training. So you'd know that machine learning models require large volumes of data. And sometimes reef data can be expensive to collect or time consuming. And so if you want to use that data to train a machine learning model, you might want to use synthetic data sets to enhance the volume of data that you have available. Additionally, another reason you might want large volumes of data is something like a sensitivity analysis. So you might want to generate a whole lot of different statistical variations of your input data set to understand the sensitivity of those inputs to your outputs. Finally, and this is the example that I'm going to focus on today, you might want to use synthetic data for testing of your model during development and exploration. So you can design a synthetic test data package to have predictable outcomes. So when you introduce changes in your model, as we're doing a lot in ADRIA because it's in active development, you can design that data set to have predictable outcomes. So if you introduce a change and you no longer get those predictable outcomes, you've probably introduced a bug. So you can set up an automated testing system to catch those bugs as they arise. Finally, you can also design a synthetic data set to have particular properties that you might want to test in your model or explore. So you can do analysis on that data set to understand a kind of theoretical scenario that might be of interest, but maybe you haven't collected data for it yet, or data is not available. So today I'm going to demonstrate a synthetic data test set that we've developed for ADRIA to test ADRIA during development. So I'll have to introduce ADRIA first. So ADRIA is a decision support tool that I've been involved in developing. It stands for Adaptive Dynamic Reef Intervention Algorithm, just a bit of a mouthful. But I'll kind of go through the key components so you can understand how we're doing this testing. So firstly, ADRIA has several input data layers. These represent things like temporal disturbances, so things like heat stress, cyclones, also important ecological information like larval connectivity and spatial context, so benthic data and that kind of thing. Then there's a series of scenario settings, so things like ecological and environmental parameters, like rate parameters that the user can set, and also intervention parameters, so the type of interventions you want to model, how frequently you want to do them, that kind of thing. Then there's the core modelling components. So we have an ecological model, which is this parsimonious mathematical model of coral survival, fecundity, growth, and recruitment, modelling 6 key coral taxa, and disturbances are applied in that model using those input data layers. We also have this spatial prioritization core, which you can choose to apply when applying interventions in your model. And I'll talk in more detail about that because it's what we're seeking to test with this synthetic data set. But basically, it uses these spatial input data layers to decide at a particular time point where is the best place to implement a restoration intervention. Finally, we have our outputs, so coral cover and composition. And you can do further analyses on these using ADRIA's metrics and analysis suite, which includes things like the techniques Pedro presented on Tuesday. So a little bit more about interventions in ADRIA. You can apply several restoration interventions, and the user can specify things like the frequency to apply those interventions, the start time, the duration. And the user can choose to apply unguided interventions, which is where you randomly apply those interventions across the spatial domain, or you can choose to apply guided interventions. And when you do guided interventions, the algorithms will use criteria to select the best places to apply those interventions. And how that works is you have a series of data layers. So there's some flexibility in the data layers that you choose to apply, but I have some examples here, so things like heat, stress, and depth. And you can choose to filter based on those data layers, so maybe there's particular thresholds you don't want to consider, so you only want to consider sites within particular depth ranges or something like that. And then you can also weight those layers according to their perceived importance for that intervention. And you can do this manually, so you choose particular weights, or you can sample weights to see what weights might be best for that intervention. But for example, if you wanted to weight heat stress as most importantly, you'd give it a higher weighting. Then those layers are aggregated into a ranking system, and the highest ranked sites are those that are intervened at. So that's ADRIA spatial prioritization. But how are we using synthetic data to test that system? So we've built this repository separate to ADRIA, which is written in Python, and it's a synthetic data repository for ADRIA's input data layers. It's built using a package called Synthetic Data Vault. It's kind of a whole other set of models, so I won't go into too much detail about it because of time constraints. But basically it takes the original set of data, and there's a synthetic data model for each of the input dataset types, and they're chosen based on whether it's temporal data or spatial data, basically on the type of dataset. And those synthetic data models are used to produce synthetic data. And the models allow spatially conditioned sampling, so there's spatial consistency in your final synthetic dataset. And what that allows us to do is we can easily create synthetic data sets of different sizes, so different numbers of reef sites, different spatial configurations, and based on different original data sets for different purposes like testing, publications, and exploration. So using that synthetic data repository, we created a synthetic test data set for ADRIA. It's a small test set, so it has 10 sites so that our tests run really quickly. And the properties of those sites have been tweaked to have certain properties. So 3 of the sites in that set are always cooler on average over time. 3 sites are always hotter on average over time, and the rest have kind of average properties. We've also set it up so that 3 sites are highly connected in terms of larval connectivity, and also receive larvae from some of the more kind of average temperature sites. And so now what we do is we have this automated testing set up where we check that when the site selection algorithm is run, those 3 sites should always be selected, otherwise we've introduced a bug. And we can do this for all different, many of the different criteria layers, data layers that we have. So this is just one example, but we run many of these tests to check that our site selection algorithms are working as expected as we introduce changes. So now I'm going to use this 10-site test set to actually run through ADRIA to show you what some of the outputs look like. And of course, this is a very simplistic test set, so it's not to say like this particular policy should be taken when choosing sites to implement interventions, but it's kind of to show how you can test particular properties of a site using synthetic data if you were to use a more complicated synthetic data set, and also how you can use synthetic data for testing. So we have our synthetic data repository, as I said, where we can flexibly create data sets with different numbers of sites, spatial configurations, and from different original data sets. And we can use this to design input data sets to understand how different management scenarios could play out and ask questions. So I'm going to illustrate this with our simple 10-site test set. So first of all, doing some runs without intervention. So this is 4,000 scenarios at SSP2 or RCP 4.5. And this is just the absolute coral cover over time. So then we can compare that for our 10-site test set to when we do unguided interventions. So this is where we randomly apply restorative interventions over 15 years starting from 2030. And you can see that for our test set, there is some benefit to applying interventions, although that benefit kind of peters off as the intervention period finishes. Finally, what happens if we apply guided interventions? So here we've used heat stress as a criteria, so we're favouring sites that are cooler, and also using larval connectivity as a criteria, so we're favouring sites that provide larvae to cooler sites. And we can see that there is some benefit when we do that. So this is kind of a test that our algorithms are working as expected, because with large domains, it can become quite complex with complicated connectivity and other factors. So a bit of a rapid tour through ADRIA and the Synthetic Data Repository. But ADRIA is a reef decision support platform that uses input data layers as criteria to select sites to apply restoration activities at. And we've developed this synthetic data repository to test ADRIA, to explore its properties and assumptions, and provide automated testing during development. And so, as I said, we can generate input data sets of different numbers of sites with different spatial configurations and using different original data sets. And this gives us flexibility when creating synthetic data sets for ADRIA for demonstrations, for testing, and to explore particular site selection questions, and also to explore broader questions. So we're interested in generating many different input data sets to understand the sensitivity of our site selection decisions to our outputs. Yeah, and as I said, this test data set that I demonstrated today was very simple, but you can imagine how you could build on that simple example to explore different questions about site selection. So thank you. ADRIA is available on a public GitHub repository, as are the synthetic data models we've built, and there's a paper that's in the works for ecological informatics on our synthetic data models.
Thank you very much, Rose. There's time for one question. I was just one. Yeah, sorry.
I think I can hear you.
No, I don't mind. It's for the online. Yeah.
All
right. Great talk. I was just wondering, how long did it take you to create this data set, and how much longer it would be the more complex the model you are creating for would be, you think?
Sure. So a lot of the data can take, like the original data can take like for example, connectivity can take days to weeks. The synthetic data models, they do vary on the number of sites that you're trying to create. At the moment, it probably takes like 4 hours to create all of the different data sets. And that includes kind of playing around with like what spatial configuration you want and that kind of thing. So it's not like a tiny amount of time, but compared to the time it takes to create a lot of these original data sets, it's quite small. So, yeah.